Hello everyone, we are going to continue with our states of matter. This is the same PowerPoint, however, we are going to get more information as we go through this. Remember, we are trying to answer our essential question number 2. You guys can look this up in Schoology. Essential question number 2. What is the relationship between states of matter and energy? So we're going to focus a little bit more on that now that you guys have your vocabulary built up. You guys understand what the states of matter are. We're going to be moving through this question. So again, we're talking about the states of matter. Think to yourself and try to remember, how many states of matter are there? So we talked about the conservation of mass. This says that mass cannot be created or destroyed. Go ahead and repeat that to yourself in your head. So yesterday we talked about this being super similar to something else that we learned. Try to think about what that is. So it's not the conservation of mass, but if you thought conservation of energy, you are absolutely right. Nice job. So conservation of energy states that energy cannot be created or destroyed. So as we go through this and our energy is changing, try to think about where energy might be going. So we have 3 states of matter. We have a solid, liquid, gas. And each of these has a different movement. Now we talked about this earlier. Try to remember, even by looking at the picture, you should be able to look and see what each state of matter does based off of what it looks like it is doing. So starting off with a solid, think of your phone. What does your phone do when you get a phone call? It vibrates. So I'm going to put a V for vibrates. We'll have the V shaking. So everyone thinks solid, vibrates. And a liquid is going to slide. So as we do our L for liquid, it goes down a slide. So liquids slide. And our gases, they are going to bounce. And they bounce against each other. And they bounce against the container that they are in. So whether that's the classroom and they're bouncing off the walls, whether you take a deep breath and that's inside your lungs to give it air to fill your lungs up, whether it's a balloon, you blow up a balloon, it gets filled with air. The particles, the gas inside of there is going to be bouncing off of the balloon to give it its shape. Same thing with this glass container. The gas particles are going to bounce off the walls. We also talked about the energy that is in each state of matter and how they're all different. So we talked about a solid and it vibrating. And since it's just vibrating, it doesn't have a lot of energy. Versus gases, those are bouncing all around against each other, against the walls, literally bouncing off the walls. Think of a kid. If we say that they're bouncing off the walls, they have a lot of energy. They are hyper, lots of energy. So gases have a lot of energy. And solids don't have as much energy. So gases have a lot of energy. Solids don't have as much energy. Liquids, they slide against each other. The particles slide against each other. And they don't have a lot of energy, not as much as a gas, but also they still have quite a bit of energy because they're not only just vibrating, they're doing more than vibrating. Remember, oh, not too sure what happened there, but something to help us remember is that as it goes in a circle like this, it's gaining, and then boom, just like that, it's losing. So again, it's gaining. Once it gets to its peak, it starts losing again. All right, going the other way. So we've got our three states of matter. We've got solid, gas, and liquid. So if I have a solid and it becomes a gas, do you think it's going to be gaining energy or losing energy? Something that I want you to do to help you out is write down for each one, like our solid, our gas, and our liquid, write down what each molecule is doing inside of the state of matter. So like, what is a solid doing, what is a gas doing, and what is a liquid doing? I'm going to give you a couple seconds to write down what it's supposed to be doing. You can go ahead and pause this video if you need more time, but write down, what is a solid doing, what is a gas doing, and what is a liquid doing? So if you said that a solid is vibrating, oh, you can't see that color. The solid is vibrating. A gas is bouncing. And a liquid is sliding. You are absolutely correct. So now think to yourself, like a little vibration versus bouncing off the wall versus uh, like going down a slide. Which one has the most amount of energy? And as we go through this, think about whether it's gaining or losing. So if I have a solid and it becomes a gas, just immediately, boom, you snap your fingers, it's a solid, now it's a gas. Do you think it's gaining energy or losing energy? One thing to help you out is look at this arrow. Is the arrow going up or is the arrow going down? If you said it's gaining energy, you are absolutely correct. Okay, now what about a gas to a liquid? Do you think that is gaining or losing energy? Again, use your tools. See how it says bouncing, see how it says sliding, and this arrow going down. What do you think is happening to the energy? If you said it's losing energy, you are absolutely correct. Now, if we have a liquid to a solid, now that's a flat line. At least it looks like a flat line. Do you think that it is gaining or losing energy? Now, for this one, you're going to really have to rely on the movement that it's doing. So we've got a sliding liquid to a vibrating solid. Which one seems like it does more? If you said a liquid has more energy, so it's losing energy to become a solid, you are correct. Good job. All right, well, great job today. Come in ready tomorrow, ready to do an activity. Have a good day.